Good morning, everybody, and welcome to this first breakout session of the AWS Summit 2024. If you're working for an industrial manufacturer, or maybe an energy and utilities company, or you're just interested in what digital twins and private 5G can do to optimize your operations, then you're in the right place. My name is Chris Wood. I'm a startup specialist solution architect working for AWS. And an IoT field specialist. Today I'm joined by Joao from Vodafone Business. He's an enterprise architect specializing in 5G, edge and APIs. So let's start with a question. Firstly, how many of you believe your companies will still be here in 10 years if you don't change? It's an obvious question and the answer's obvious as well, maybe if you disagree, but 45% of CEOs agree that their companies will not exist in 10 years if they don't change with the times. 56% think that operational agility is the critical factor to enable their organizations to change as well. In the manufacturing and industrial sectors, we think of operational agility being delivered by Industry 4 projects or smart manufacturing projects. So let's look at smart manufacturing. The International Society of Automation thinks about it in terms of improving performance through integration and intelligent use of your resources, but also collaboration across different domains that you may not have collaborated with before across your entire value chain. So this performance could include agility, but also safety, efficiency, and sustainability. Other domains could be engineering, logistics, marketing, anything outside the production line. Looking at this in a different way, it's about the ability to be able to see real-time data for visibility of the shop floor, to be able to respond to that, to dynamically schedule in order to optimize your machines for energy efficiency or productivity. And then it's also about being able to predict the future to maximize your availability and optimize your yields. People that do this right are achieving up to 20% productivity improvement and 10% energy reduction. So much so that nearly 70% of manufacturing firms have already started a smart manufacturing project or will do within the year. It's obvious that this is all going to be underpinned by data, and manufacturers have lots of it. 1,800 petabytes is being generated every year. The problem is 90% of that is remaining siloed. And 70% of projects are failing to deliver their full potential. If we drill into this, 40% say that the main problem is with integration. This is integration of legacy equipment and protocols. The ISA 95 standard is a little bit out of date and encourages those silos. It's causing data to be too localized. And even if you have local successes, it can't be scaled. Data formats are inconsistent, solutions aren't repeatable, and data is not being democratized across the board. Connectivity dead spots in factories from fixed legacy cabling and security fears are also hampering data capture from the edge from sensors, machines, and controllers. Today, we're going to help you solve those integration challenges by introducing an industrial data foundation. We're going to look at 3 key use cases that customers come to us for help with. Then Joao is going to talk to you about how to get that connectivity decision-making right. And finally, we're going to end up with a little tour of the Edge Lab that we've built with Vodafone Business in Salford Quays near Manchester. So let's get started by talking about a typical edge to cloud journey and an industrial data foundation that can help with that. The typical journey usually starts with sensors or controllers or other systems generating data at the edge. These machines and sensors are emitting data, but in order for an operations director to turn that into insightful changes, that data needs to be ingested at the edge, and maybe you might need to do some transforms, some buffering, and compression before you send that data to the cloud for ingestion and storage. Critically, you then need to add context to that data to make sure it makes sense within your organizations and makes sense to all the people that are going to need to use the data. Once it's understood, you can start to run predictions, maybe using machine learning or traditional physics models to be able to simulate what-if analysis of the future. You also might want to visualize that data to bring the human mind into play and visualize it through 2Ds or 3 dimensions or even 4 dimensions across time. And once you've decided which optimizations you want to make, you need to get those back to the edge in a safe and secure way so they can be applied on the line itself. All of this needs to be underpinned by reliable and secure connectivity at the edge as well, otherwise you're not going to get anywhere. Thinking of this in the technical domain, there's an awful lot of functionality you need to deal with across a whole number of tiers before you can get to that insight and adding value. It's a lot to look at once, so today instead of walking you through the stack, I'm going to take you through a number of key use cases and explain the architecture that's underpinning it to build up an overall simple starter architecture for you. So let's get started with the main thing and the principal thing that customers come to us in industrial scenarios, and that's being able to take their data from a production line and monitor it at a global level. Kingspan is an excellent example of this. They're a building group with 50 factories spread across the world, but each has its own individual data capture and collection system. They were struggling with lack of availability and had a manual process that was generating audits, and this was taking up to 3 weeks to execute. It was difficult for them to get their data out of siloed historian servers and manufacturing execution systems. This was restricting their growth and their ability to be agile and improve their processes. AWS Premier Partner Storm Reply worked with them in order to implement an asset monitoring and prediction solution that was able to ingest that data from the edge and move it to the cloud. This allowed Kingspan to monitor their plants and assets in real time and provide insights on their performance and efficiency across the world to executives, managers, and operators wherever they were. Asset monitoring prediction, also known as AMP, is built on AWS IoT SiteWise and uses those native services for industrial data. Using Managed Grafana as a dashboarding tool integrated with SiteWise, Kingspan can now visualize, query, and run optimizations on that data to understand metrics no matter where they're stored. Staff at all levels are now able to make data-driven decisions, and those reports that were taking up to 3 weeks to generate can now be turned out in 3 minutes. The IoT in a box solution that Storm Reply delivered can now also be rolled out across the world to existing factories or new factories as they're rolled out. It's interesting to think about the heavy lifting that SiteWise is giving to this data process in a bit more detail at Kingspan. We love to talk about undifferentiated heavy lifting at AWS. Well, this is a great example of differentiated heavy lifting in the industrial space. This is a Gorilla class 900-ton oil rig, and it needs a very specialized cargo ship to be able to move it from one place and reconfigure it for another job in another part of the world. That ship, you can see on the left, has sunk itself to the seabed as the rig is moved into place, and then floats itself up and moves away when it's ready to go, which takes a long time, but it also takes years of experience and specialized machinery and processes to do that. It also takes years of experience and specialized processes to build an industrial data platform yourselves from scratch. Now, if you want to be differentiated for that, that's great, but most customers want to get going quickly and start adding value straight away. So this is where managed services like AWS IoT SiteWise gives you such a great kickstarter to get your industrial journey moving fast. Let's take a look at how SiteWise helps in this global monitoring example. So the first thing I wanted to talk about was capturing industrial data, but putting it into context. Raw data streams captured from machinery need to be put in context to be meaningful. And SiteWise helps you do that by creating asset models in the abstract. You can define things like asset properties, the manufacturer date, the manufacturer's name, but also the measurements that can come from those assets. They might be sensors, a PLC, or a piece of industrial machinery, and you can set those up in a model that then can be reused across the industry and the business. Additionally, you can define your own metrics and KPIs that are using those measurements to run calculations on the fly across those asset hierarchies as well. And this is really important because you can define metrics in a standard way that then can be applied across your organization, so you can compare like for like when you're comparing one plant in one country to a different plant in another. It's important here to note that SiteWise is actually providing a streaming analytics engine to run these calculations on the fly. Now, you could do all of this yourselves. You could use streaming technologies like Kafka, Apache Spark, or others to build a streaming analytics platform and manage it and run it yourself. But with SiteWise, you can do that through just writing your functions into the console or through an API, and just get going, adding value immediately, and focus your people on optimizing your performance. So we've said those models can be applied to assets across the world, and then you can then define links between those data streams coming in raw to the particular properties of the assets, which then drives that metric generation in real time. You can then query that data directly from SiteWise using low latency APIs for your applications, or you can use the new SQL interface if you're using it in a more BI context. The other new feature that came out last year is the ability to extract the entire asset hierarchy into a flat file, so that you can either use that to promote an asset definition through a development lifecycle, or to take all of the assets from one facility and deploy them with changes to another place across the other side of the world without a line of code. So in order to get that data into SiteWise, you're going to need to ingest it. So let's look at a few ingest patterns that are most typical. If you already have assets that are connected to the internet, you may be connecting to IoT Core over MQTT or via LoRaWAN. There's already a pre-existing connector to SiteWise, so without any code, you can push your data straight into the SiteWise APIs. If your data's already sitting in the cloud, you can also push it through SiteWise APIs using the AWS SDK and a Lambda function, for example. However, in most industrial scenarios, you're going to be sitting behind an industrial network which is isolated. Your assets cannot access the internet. So you're going to need an industrial edge processing device that's typically sitting inside DMZ or your local corporate network. In this case, the edge processing device is responsible for connecting to your assets using a variety of protocols, dealing with the variety of frequencies that those assets are emitting in. So your sensors may be emitting multiple times a millisecond across your plant floor. You may be querying a historian every few seconds, and maybe your PLCs are only reporting outages where there's a state change that looks suspicious. Your edge processing device then is responsible for buffering that to deal with the differing frequencies and send that securely and reliably to the cloud. In the AWS world, that edge processing device is typically SiteWise Edge running on Greengrass. So let's take a closer look. AWS Greengrass, if you don't know, is edge software that's deployed onto devices to enable you to deploy components either to a single device or a whole fleet of devices through a deployment. It also deals with secure connectivity back to the cloud and can give you extra features such as remote tunneling so that you can access your edge gateways behind a firewall. One component that SiteWise uses to deploy onto Greengrass is the SiteWise Edge Data Collection Pack. That gives you the capability to connect across a number of industrial protocols such as OPC UA, Modbus TCP, or MQTT to your assets. And then through using Greengrass streams, it securely buffers those and then uses a publisher to push that data into SiteWise in the cloud. However, most of our customers actually need to do stuff at the edge as well. It's not just about extracting the data to the cloud as quickly as possible and running reports. They need to possibly run in an isolated environment. This is where the SiteWise Edge Processing Pack comes in. So again, the configuration for this is done in SiteWise in the cloud. It creates a script for you to run on your edge and automatically deploys a processing pack. But alongside the basic components, there's a time series database that can store data at the edge for up to 30 days. So all of that data is initially stored in the time series database. Those models of the assets that we defined in the cloud are also deployed at the edge. So the configurations such as KPIs, for example, the overall operational effectiveness of the plant, are calculated at the edge instead of at the cloud. SiteWise Edge then gives you the ability to choose whether or not to store the raw data at the edge and send it to the cloud, or just send the metrics to the cloud and leave the data, the raw data at the edge. This means that you can optimize the bandwidth of your connectivity and potentially reduce your costs. In order to use that now streaming raw data plus the telemetry and the KPIs, SiteWise offers most of its standard cloud APIs at the edge as well. This enables you to drive local applications and dashboards, use the SiteWise monitoring tooling if you like, and also extract that data into any local BI tools and things that you've got running at the edge as well. So because SiteWise Edge stores the data for up to 30 days, essentially you can run for nearly a month completely isolated. The last capability I wanted to talk about in an industrial data platform is storage. So this is critical. Once the data is in the cloud, SiteWise offers 3 tiers of storage. There's a hot tier storage available. Now this is for high velocity applications, so it gives you low latency application access via APIs to the raw data and the KPIs. But we also offer a cold tier, so you can configure SiteWise every 6 hours to export that hot tier data into a structured set of buckets in Amazon S3, which forms cold tier storage. This is more appropriate where you want to store data for a long period, but you don't want frequent access to it. Recently, we also offered a warm tier. Now this is a compromise between those 2 storage tiers. So it's for frequently accessed data where you can afford to have slightly higher latency, but want to keep the data for, say, a year or so. This is great for analytics reporting and machine learning, where you want to get data into those tools simply and quickly, but you don't want to struggle with getting it out of S3. Next up, to get that data into the cloud and drive those edge connectivity cases, you need to get your connectivity decisions right. Joao's now going to come up and talk to you about private 5G and other options that you have to make those decisions. Thanks, Joao.
Thank you, Chris. Often, we take connectivity for granted until it fails or is just not good enough. What if 1 millisecond latency can save millions on bladed disk manufacturing for jet engines? A study has identified that the use of 5G-enabled vibration sensors can act on time and correct the cutting of the blade on the CNC machine to save those millions. And it's just a split of a second. Today, I'll help you design for 5G private networks, edge computing, and talk about the trade-offs about it. Imagine that if you are in the Excel as a gigafactory. Gigafactory are huge plants to produce electric vehicles. They need scale and they need agility. They need scale that often comes with autonomy, with automation, and agility that comes with wireless connectivity. And the production processes cannot tolerate intermittent network failures or coverage blind spots. Creating a target architecture is essential to look at how we design and also how we fit a solution that meets our purpose and requirements. But there are a lot of options for connectivity, from Wi-Fi to private 5G to LoRa. But first of all, we need to understand what our goals, what our use cases are. And this is where, for today, for the Excel, I would like to bring 3 types of use cases: autonomous guided vehicles, connected workers, and temperature sensors, for example, on a spray booth, or even a parking sensor for the vehicles we just produced in our electric manufacturing plant. But with so many options, what are the trade-offs? LoRaWAN is known for its wide coverage and also low power consumption. So it can normally fit into environmental monitoring or asset tracking. Wi-Fi is known for high data rates, low latency, but not really for mobility. And this is where 5G high data rates and also carrier-grade security for mobility is perfect for the autonomous vehicles and also remote-controlled machines. What about drones? Well, you kind of guessed it, it's 5G. And with edge computing, we can bring that low latency and also the reliability for the connectivity needed for these devices. Combining technologies drives a better solution. And now let's deep dive a little bit more into 5G. 5G is not only for consumer. It's been designed for the industry, and manufacturing can benefit from it. This quote is from the 5G standard, and it effectively shows that 5G can drive the agility and the efficiency across the factory floor. And what are the key features for manufacturing that we can use? We have 5G is designed for mission-critical communications, like worker safety, security, or AGVs, to carry parts from the dockyard outside into the factory floor. 5G is designed to support millions of devices, millions of IoT devices. And millimeter wave transmits data a lot more faster and enables that millisecond latency that we talked about before. And what about spectrum efficiency? 5G has been designed to cover all the ranges of spectrum that we had in the previous technologies, but also the high band or the millimeter wave that can allow you for high data rates in a short coverage. But this is where, with so many options, we need to take some decisions when designing one. But what if we could bring all these features in a box to the factory floor? And that's a mobile private network, private 5G. It brings the additional benefits from 5G, but also allows data to stay local with edge computing and adding guaranteed quality of service. The devices stop fighting for bandwidth. This architecture reduces the silos and network hops we can find today in our factory floor. And it also reduces single points of failure. And it's secure. It's harder to hack because it was designed with that assumption in mind. 5G security architecture spans across the user equipment, the RAN, the radio access network, the core network, and it has a lot more features on it. We could delve into the protocol stack today, but I think that would be too much for this session, so we can do it for the next one. But how can we choose between public and private 5G? There are several options. We have dedicated mobile private networks where the customer has 100% control, and the data generated stays on premise or is aggregated to the cloud, which is a key requirement for manufacturing. But if we require the wider coverage, let's say for asset tracking across the country, we can use a hybrid MPN, where it brings the benefits of both worlds, both the dedicated on-premise, but also the public network. And then we have network slice. Network slice is where the applications run on our public networks, and they have guaranteed quality of service. and you can control them via network APIs. And that meets the needs of our customers. One big example was last year King's Coronation, where we deployed the 5G private slice. And now let's take a closer look. Mobile private network is built of radio components and a mobile 5G and 4G core. And also edge computing to run the digital applications we need to further reduce the latency for the machine control, but also to provide reliability of output and input of data, and make it available on the fly with dashboards like AWS IoT SiteWise Edge. Then we connect it to the OT network with sensors and PLCs via 5G. And 5G is everywhere. It's across the factory floor through 5G routing, but also is connecting high-definition cameras, our automated vehicles, and our connected workers with sensors or wireless tablets to support what they need to do. And one of the benefits is also that you can connect all the other networks from Wi-Fi to LoRa to Bluetooth into Edge, bringing to life the meaning of multi-access edge computing. With all of this, with a managed service from Vodafone, and because it looks like this, it doesn't look like a data center. It can stay on the factory floor, and it can connect what you need to connect on the factory floor. Thinking about the applications, we also need to think about what edge computing brings. Edge computing brings running applications where and when we need it to run. We have dedicated edge computing together with private 5G that allows to keep the data where we need it and enable the factory of the future. And we also have distributed edge computing with AWS Waveland, which is a partnership between Vodafone and AWS, where you can run optimized workloads for our 5G networks in a Vodafone data center with AWS hardware and the experience that you have from the AWS console. Some examples for this are stadiums, smart traffic lights technology to reduce traffic congestion, and I think we really need that. Now let's take a look into a customer challenge. Bayer in Germany wanted to connect and get benefits from the new technologies. And that means that in 11,000 square meter greenhouse, they wanted to gather the insights in insecticide research. The challenge was that there is a wide variety of climate conditions that are simulated, such as temperature and humidity, but also day length and temperature and air filtration. What are the benefits? You can bring AI computer vision and fully autonomous robots to work on these large data sets and be able to learn more about the plant health quickly. And with these insights, you can look into innovative solutions both for research but also for the field. And this is done with 5G private networks. To sum up, you should have learned more about how to get connectivity right, what 5G private networks are, what edge computing means, and what trade-offs you can make. And you still have a lot more to learn today. I'll hand over to Chris.
Thanks, Charles. So next, now we understand how to connect our assets and get that data to the cloud. The next thing that customers come to us asking for help with is the ability to predict the future, specifically to look at anomalies and try and predict failure. A fantastic example of this is Toyota. Toyota manufacturing in Kentucky were running more than 200 CNC machines 24/7. But their maintenance team was struggling to identify high priority maintenance tasks before they could avoid downtime. And they were experiencing 40 hours of downtime every month. They didn't have the in-house skills to be able to deal with large volumes of data or build those machine learning models for themselves. But using AWS IoT SiteWise and Amazon Lookout for equipment, they were able to launch a solution that could predict failures in those CNC machines days in advance. This led to their operational availability increasing by 10% over the rolling 12-month period. And they actually reduced their downtime every month to 20 hours. They've now scaled this out to 300 assets in that plant, and Toyota are in the process of rolling the solution out across the whole of North America. So how did they do that, and how can you do it for yourselves? It's actually quite easy, because SiteWise is now tightly integrated into Amazon Lookout for Equipment. If you don't know, Amazon Lookout for Equipment is one of our ready-to-use machine learning services, which allows you to build anomaly detection models from sensor readings like temperature or vibration or humidity, or other state-type information like whether an asset is on or off, or whether it's experiencing some issues that in real time. So you can add categorical data as well to help train the machine learning model. One thing that makes the Toyota case study particularly interesting is that we normally associate these types of automatic prediction models with continuous running machinery, such as pumps or motors or engines. The interesting thing about Toyota is those CNC machines were switching themselves on and off. So it's a great example of adding extra data in real time about the state of the machine in order to give hints to that neural network when the model's being trained. But the important thing is that you don't actually need to worry about any of that. All you need to do is define what data you want to use to drive the model. So within SiteWise, there's now a prediction section within that modeling area where you can define of all of the measurements and those KPIs that you were defining before, you can choose which of those you think are most appropriate to identify problems with that asset. So you might do that from subject matter experts, or you might do it just from trial and error. And you can use up to 300 different signals for each asset, and use some of the features within Lookout for Equipment will help you understand which of those signals are most significant within the anomaly detection process. But suffice to say, you just choose which fields you want. SiteWise will then export those automatically into Amazon S3 in the format that Lookout for Equipment requires. So you could do this yourselves previously, but you'd have to do a lot of data wrangling to prepare the data for Lookout for Equipment training. Once the data set has been exported, Lookout for Equipment will automatically ingest that into its training data set. And when that's done, you'll know, and within SiteWise you can trigger a training job. Now it's important to know that you might want to train to start with at the beginning in order to experiment and then find something that works and put it into production, but you probably want to keep retraining over time, as maybe different configurations on the production line mean those signals mean different things. So the ability to do that from SiteWise is really useful without having to manage ML pipelines or any of that type of automation. Suffice to say, once the model is trained, you can then set up an inference schedule also within SiteWise to run inference using that model against real-time data coming through and being stored on an ongoing basis. So you may want to do that daily or weekly or whatever you think works best for your assets. Once those inference schedules are triggered in Lookout for Equipment, the results, which are detected anomalies, are sent out to Amazon S3, and the state of the asset, whether there's currently an anomaly detected, is also integrated through to SiteWise, so you can see it there too. Along with just the fact that there is an anomaly, you also get a breakdown of which of the signals were most contributing to that particular anomaly detection. And that gives your analysts a real head start in looking for root cause analysis. Because of that contextual model, you can associate those signals with particular parts of the asset hierarchy and hopefully isolate where the problem lies. Okay, so that's how our customers are doing predictive maintenance. Let's look at another really popular use case that we've been doing a lot of work with over the last 18 months, and that's digital twins. And we like to think of customers connecting digital twins in both space and time. That comes from the two main use cases that customers ask us to help with. The first is remote worker or remote expert, where they want to have a production line on the floor workers connect to an expert anywhere in the world. As their plants expand globally, they can't afford to have machine experts or engineers sited everywhere. And so it's important for someone on the ground to be able to get help in a timely way. Talking about time, the other type of usage for digital twins that customers have is health and safety training or familiarizing new workers with an environment. So in this case, we can take that real-time streaming data that we've stored before and replay it to simulate previous examples of health and safety incidents or problems that have occurred, and then also use simulation and also historical outcomes to be able to show those users what the results of their actions in that training session would have been. In this way, the team can build up their muscle memory, so when those problems happen in reality, they can respond quickly and effectively and safely. So let's talk about what the definition of a digital twin is to start with. We think of it as a living representation of a physical system that looks at the dynamic state, the behavior and the structure of that physical system, but that it's used to drive business outcome, and that's the critical thing. Let's look at how John Deere have driven business outcomes in the remote worker space. So this is a quick video showing how a remote worker can raise a task for an expert to come if they've got a problem on the production line. A manufacturing engineer can then take that task and quickly jump in to a 3D environment and see real-time data overlaid on a photorealistic model of that environment to familiarize themselves with what's going on. They can chat live to the worker, and if necessary, they can start a live video chat, or using an Amazon Kinesis video streams for WebRTC connection, they can look at a live video stream in extremely low latency. Kinesis video streams for WebRTC gives you such low latency that you can actually drive equipment or automated vehicles remotely. So that really helps find out whether the person on the ground has done the right thing, or to actually be able to physically help them in that task. Once they've verified that the job has been done correctly, they can approve that and then move on to another session with another worker somewhere completely across the world. So let's quickly look at how they did that with AWS IoT TwinMaker, which is the system that underpins that user experience. TwinMaker gives you features across 4 main areas. The first is data connections, and that's really critical. You need to be able to connect to that data in SiteWise or other systems quickly and easily. And IoT TwinMaker gives you out-of-the-box connectors to SiteWise, and additionally gives you the ability to sync those whole asset hierarchies behind the scenes without actually doing any work. But you can also connect to your own custom data sources, for example, an ERP system, by building your own connectors using an extensible framework. And that might connect you with historical maintenance records, live data coming from sensors, or production state changes and things like that. The other thing you might want to connect to is video feeds, as we saw with the John Deere example. So in this case, you would connect metadata about the video feed, such as the RTSP stream or the Kinesis video stream's name. The last thing we wanted to talk about was connecting machine learning and physics models. So in order to run simulations, you might be able to train some predictions using machine learning or more traditional physics models in batch. So things like that, those lookout for equipment results could easily be brought into the digital twin and overlaid to identify assets that have problems. But you might also want to set up a data source that queries an endpoint in real time to run inference every time the digital twin is refreshed. Once your data sources are set up, behind the scenes, TwinMaker actually sets up a knowledge graph that enables you to run queries that will traverse the graph and for things like root cause analysis. And this connects those data sources together where they may not have been connected previously. So that the same asset can be traced from the ERP system all the way through to the factory floor. You can actually create associations within that knowledge graph that don't even exist in data, just by making associations manually. that's the data side. So the other area that TwinMaker really helps with is visualization. You can bring in point cloud scans for photorealistic environments or more traditional CAD and buildings information models. And once you've done that, you can overlay the data sources to create user experiences that have things like simple data overlays or representations of things like speed or motion or state within your asset hierarchy. Finally, you want to embed that experience within your applications, and we provide an app toolkit to do that into your own custom web and mobile apps. But to make things simple, and also to get quickly running with prototypes, for example, there's a plugin for Grafana that helps you get running straight away without any code. Okay, so we've talked about digital twins and predictive maintenance and also just getting your data in. Let's look at all of that brought together within the Vodafone Edge Lab, which is an industrial demonstrator we built in Salford Keys in Host. First up, I wanted to take you through the architecture and how that's built up, which really reflects that foundational data architecture through the use cases we've built on it. So we started off with actually some equipment that our sensor manufacturer and partner IFM provided for us. There's a motor and fan assembly plus a small conveyor belt with some products going around on it. They've overloaded that with lots of sensors for demonstration purposes, but primarily there's vibration and temperature sensors on the fan, and there are product inspection sensors on the conveyor belt. Those are connected using IO-Link, which is an industrial protocol that enables you basically to plug and play those sensors and actuators and collect those into an industrial edge device without really having to write too much code or do any translations. It's able to actually infer which signals the sensors are providing automatically. Those are pulled out through SiteWise Edge using the OPC UA protocol and pushed to the cloud. And we're using 5G, a private 5G MPN at the edge to connect both the Moneo IFM server that's collecting and providing an OPC UA server, as well as SiteWise Edge, which is actually running on a device that's natively 5G capable. From there, we're connecting to look out for equipment, and we're also connecting to TwinMaker using that automated integration and Amazon Managed Grafana. We're pulling in a point cloud scan from our partner Matterport in real time, actually, in the environment, and our partner Treedis has built a 3R completely immersive experience on top of both the Matterport scans and the real-time data coming through TwinMaker. Finally, we've installed a webcam, and using Kinesis Video Stream's Edge Agent, we're live streaming the conveyor belt out to that experience in the cloud in Grafana as well. So what does that look like? Here's a quick look at the dashboard. So here we can see the components of your overall equipment effectiveness, showing an OE line metric. We can see that there's been some active alarms, so actually that OEE isn't so great at the moment, and we can see the recent history of the states of the assets as they're running. We can look at how that's changed over a longer time period and do some day-on-day comparisons to make sure we're improving in performance. We can see there's some problems here, so let's go back to a previous time period and verify, yeah, the conveyor belt was running before, but we can see now that it's stopped. So I'm going to dive in to look at the conveyor belt monitor in a bit more detail. Here I can see recent stats and metrics about those product inspections to find out, yeah, I can see at the moment there's nothing coming off the production line, so I suspect it's stopped. At that point, the operator can jump into the 3D environment, see a reflection of that state, and look at some metrics in real time. So this is real-time streaming data coming through. I can see also the metrics from the cooling fan. So I might want to actually go through and have a look and see if there's any problems brewing for that. And using some of the IFM sensors, which actually isolate frequencies that are associated with things like bearing wear, I can check that everything's all right. Everything's all right there, but now I want to maybe look at a live video to see what's really going on that conveyor belt. And yeah, I've confirmed that it's stopped, so now I'm going to raise a task for an engineer or a production line person to go out and press the green button to get it started again. So just in the corner there, you can actually see the private MPN mobile network provided by Vodafone and how small the antenna array is. Those are the dots that you can provide everywhere. So I hope that gives you an idea of what you can do. We've looked at data connection, we've looked at some critical use cases that customers need help with and how to bring that all together in a standardized architecture. If you want to actually have a look at the Edge Lab yourselves, then get in touch with your AWS account manager, and they can organize that with Vodafone Business, so you can see and talk about your requirements in more detail. If you want to read about what we've done, there's a great blog post for you there. You can also read about mobile private networks in more detail, and if you want to get hands-on with IoT TwinMaker and IoT SiteWise, there's a fantastic lab for you there. Don't forget that Skill Builder provides lots of industrial IoT courses and videos for you, as well as lots of courses in other domains. So thank you very much for listening today. Thanks, Yael, for joining us, and have a great rest of the summit. Please don't forget to scan this and give us some feedback. And there's a great industrial IoT session coming up at 1:15 about the analytics and doing more with overall equipment effectiveness. Thank you very much.
Thank you.